Alright, so we're going to do section 9.3, page 461, number 1, which reads, show that e to the x grows faster than the polynomial x cubed minus 3x plus 1. Now we're going to let f of x be equal to e to the x, and we're going to let g of x be equal to the polynomial x cubed minus 3x plus 1. And according to what we've already learned in section 9.3, if f of x grows faster than g of x, then in the limit as x goes to infinity of f of x over g of x, that's going to be equal to infinity if f of x grows faster than g of x. So let's substitute our two functions into this limit, and we're going to see what happens. So we've got the limit as x goes to infinity of e to the x over x cubed minus 3x plus 1. And if we just substitute in, then we're going to get infinity over infinity. And as you recall from earlier in chapter 9, this is an indeterminate form, which means we get to apply L'Hopital's rule. And as you remember from when we apply L'Hopital's rule, we still take the limit as x goes to infinity, but now we take the derivative of the numerator separately from the derivative of the denominator. So the derivative of e to the x is of course going to be e to the x, and then we're going to use the power rule to take the derivative of the polynomial. So we're going to get 3x minus 3, and if we substitute in again, we're going to get infinity over infinity, which is the same indeterminate form, which means we're going to apply L'Hopital's rule again. So again, I'm going to have my limit as x goes to infinity, and again I'm going to take the derivative of the numerator separately from the derivative of the denominator. So the derivative of e to the x is still e to the x, and in the denominator I'm going to apply the power rule, and I am going to get, oops, that should have been a squared up there, so now I'm going to get 6x, and I'm going to substitute in, and again I get infinity over infinity, which is still the indeterminate form. So I'm going to apply L'Hopital's rule one more time and see what I get. So I've got the limit as x goes to infinity. Again, the derivative of the numerator is e to the x, and the derivative of the denominator is now going to be 6. So when I substitute in, I'm going to get infinity over 6, which is in fact infinity. And this shows that my original assumption over here about f of x and g of x, now I know that my limit as x goes to infinity of f of x over g of x is in fact equal to infinity, which tells me that f of x grows faster than g of x, or as we were originally supposed to show, e of x is going to grow faster than the polynomial x cubed minus 3x plus 1.